Yo, what's up? Ricky Sanders here. If you live for fast cars, greasy hands, and solving problems under the hood, welcome to your new favourite spot. I'm all about real fixes, no BS, and showing you how to keep your ride running like a champ. So go ahead, smash that like button, hit subscribe, and let's make some noise in the garage. Enough talk, let's get wrenching.
Steam machines, as well as traditional internal combustion engines, are characterized by a common disadvantage: reciprocating movements of the piston must be transformed into rotational movements of the wheels. This is the cause of low efficiency, high wear of the main elements. Many engineers tried to solve this problem by inventing an internal combustion engine, all parts of which would only rotate. However, such a machine was invented by a self-taught mechanic who had not graduated from a higher or even a specialized secondary school. A bit of history. In 1957, the little-known mechanical inventor Felix Wankel and leading NSU engineer Walter Fried were the first to install a rotary piston motor on a car. The test subject was the NSU Prinz. The original design was far from perfect. For example, the plugs had to be changed almost after a complete disassembly of the unit. In addition, the reliability of the motor was doubtful, and the economy could not be mentioned. After many tests, the concern began to produce cars with a traditional internal combustion engine. However, the first rotary piston DKM-54 could show great potential. This is how the original type of internal combustion engine got its chance to be implemented in the production of cars. In the future, it was constantly finalized, but the prospects of the rotary piston motor were already obvious at that time. RPD is included in the classification of rotary motors as one of 5 representatives of the line. By the 80th years of the 20th century, Wankel rotary engines were investigated only by Japanese company Mazda. Also, VAZ paid attention to this motor. In the USSR, gasoline was cheap enough, and this unit had a sufficiently large capacity. However, by 2004, the production of cars with this engine stopped. Japan became the only country in which the development of the rotary engine continues. There are many varieties of rotor units. The only difference between them is the surface of the housing and the number of faces on the rotor. Different layouts of such motors are used in auto and shipbuilding. Advantages. The Wankel engine from the moment of its creation had many favorable advantages over piston engines. The unit was constantly improved, which allowed to increase its economy and performance. Among the advantages of the Wankel are small size and weight. Wankel is almost 2 times smaller than the piston engine, which has a positive effect on the controllability of the machine, contributes to the optimal installation of the gearbox, allows you to make the cabin much more spacious. Compared to a 2-stroke motor, the Wankel engine has much fewer parts. This is more favorable from the point of view of repair. Twice as much power as a standard internal combustion engine. Greater smoothness of operation. The absence of forward and reverse movements favorably affects the comfort of riding. Possibility of refueling with low-octane gasoline. All motor elements rotate in one direction. This improves the internal balance of the unit and reduces vibrations. Wankel delivers power evenly and smoothly. During the time the rotor turns one time, the output shaft makes 3 revolutions. Each combustion is accomplished in 90 phases of rotor rotation. This indicates that a one-rotor engine is capable of producing power for 3/4 of each revolution of the output shaft. A one-cylinder engine can only deliver power for 1/4 of each revolution of the output shaft. Disadvantages. The disadvantages of the engine include unaccustomedness for owners and mechanics. Such a unit requires changing many habits. For example, it will not be possible to break the PSD, and the assault of ascents in tension is doomed to failure. The compact motor has low inertia, which is not the case with massive piston engines. With frequent starts and shutdowns thrown candles. The sound of the motor. Some motorists also refer to the disadvantages. More serious are the organic flaws of the rotary piston unit. First, it has an increased fuel consumption. This is easily explained by the suboptimal shape of the chamber, which loses heat through the walls. In addition, the motor eats quite a lot of oil. The Wankel's service life is lower than that of a standard internal combustion engine. The rotor seals wear out regularly. The rigidity of the external characteristic of the rotary piston motor plays a significant role. To drive a machine with such an engine, it is necessary to manipulate the gearbox lever quite often. This is due to the short gear range and the increased number of gears required. The ideal option is to install a variator. However, automatics do not take root on sports cars, and family-type cars require more economy. The disadvantages of the RPA are similar to those of two-stroke piston units. Interestingly, it can be cured in the same ways. Increased fuel consumption is offset by direct injection, lack of elasticity, by installing variable phases. This improves fuel economy and drivability. Piping configuration is also changed to improve elasticity. Such changes have been made on the Mazda RX-8 motor. How it works. The Wankel engine works on the principle, which is simple enough to explain even to a person unaware of mechanics. The unit has a minimum of details, which allows you to quickly understand what systems are involved at certain intervals. The engine piston is replaced by a rotor with 3 faces, which transmits the pressure force of the combustion gases to the eccentric shaft. The stator has an epitrochoidal configuration of internal surfaces. The rotor has seals at the top of the rotor, and the stator surface has recesses, which are the combustion chambers. The shaft rotates on special bearings. They are placed on the housing. The shaft is also equipped with an eccentric. The rotor rotates on it. The pinion is mounted in the housing. It is meshed with the rotor gear. The reciprocal action of these gears creates the movement of the rotor. This allows the formation of 3 chambers that constantly change their volume. The gear ratio of the gears is 2:3, which provides 1 revolution of the shaft per 120-degree rotation of the rotor. When the rotor completes a full revolution, all chambers complete a 4-stroke cycle. The combustion gases act on the eccentric shaft through the rotor to produce torque. There are 3 chambers between the rotor and the stator. Intake occurs when one of the rotor tips begins to cross the fuel injection port. The volume of the chamber increases, causing the mixture to fill it. The next vertex closes the window. Like a conventional engine piston, the rotor compresses the working mixture before ignition. It is compressed and a spark is generated in the chamber at the highest compression. As a result, the working stroke is carried out. Afterwards, the exhaust window opens under the pressure of the exhaust gases and they leave the chamber. With 1 revolution of the rotor, the engine performs 3 cycles. This makes the use of balancing devices unnecessary. There are weak links in the workflow. The first is the increased load on the seals, and the second is the excessive dynamic phase overlap. The configuration of the combustion chamber is not optimal either. However, there is a positive moment. If you increase the revolutions, the speed of flame torch propagation increases faster than the fuel mixture flows over. This makes it possible to use gasoline with a lower octane number for RPM. The principle of operation of the Wankel is simple enough, which in its time attracted the attention of many car manufacturers to the invention. Interesting facts. Not every car enthusiast knows that the Wankel is one of the 5 subtypes in the classification of rotary motors. Compactness, revving, high performance. Is this not what almost all motorcycle manufacturers are seeking? It is unequivocally so. However, the rotary motor has not taken root in the motorcycle world. All bets are on classic piston engines. However, there have been a few exceptions in the history of motorcycle production. For example, in 1974, Hercules produced the mass-produced Wankel series, which were equipped with the KC-27 engine. These were rotary units that were equipped with air cooling. The engine had a displacement of 294 cc. The power of the units was 25 horsepower. To lubricate the machine, oil had to be independently filled into the fuel tank. In the early 1980s, the rotary motor was used to equip Norton motorcycles. Despite the fact that prototypes of such engines appeared in the 1970s, Norton engineers successfully introduced the RPM in the sport. By the end of the 80s they had no equal. Today the company produces a 588 cubic inch model with 2 rotors and RV588. Also, Norton engineers are developing a 700 cubic centimeters version, which is called an RV700. It is a powerful sport bike equipped with an injected 170 horsepower Wankel engine. As you can see, the era of rotary engines has not yet arrived. Piston systems are still the leaders in the field of automobile and motorcycle construction. Owners of bikes with rotary engines can only form a small circle of Wankel fans. The renewed interest in Norton's Wankel indicates that development and advancements in this area will soon be on the rise. One of the reasons why the engine is not manufactured to equip cars and motorcycles is the need for precise equipment in its production. The slightest defect causes the motor to fail. This does not yet allow the rotary unit to replace the piston engine, even in narrow industries. In conclusion, the Wankel engine stands out for its unique design and efficient operation. By utilizing a triangular rotor that moves in an elliptical chamber, it achieves a smooth and compact power delivery, making it an intriguing alternative to traditional piston engines. While it may not be as widely adopted, its innovative engineering continues to inspire advancements in automotive technology. Understanding how the Wankel engine works not only highlights the creativity behind engine design but also opens the door to exploring future possibilities in the world of propulsion. Thank you for watching, and we hope you gained valuable insights into this fascinating topic.